now we can work out for this problem. We can work out for this problem. Yes. Find out Norton's equivalent network for the figure shown below. Given is one figure, and for that figure we are interested in the calculation of the Norton's equivalent network. We are interested in the calculation of the Norton's equivalent network. The procedure will be the same. Remove the load resistance and short the output terminal. In this case, load resistance is already removed. In this case, the load resistance is already removed. Just we have to short these output terminals here and we have to start calculation. Now look at here. First step. Shorting the output terminal because already load resistance is removed. Shorting output terminals. We get. How will be the figure? The same as it is. Just time copying. Here is A. This is B. Here it is 12. This current is 3 amperes. This is 4. And this voltage is 24 volt. Is it right? And we have to short these output terminals. Now look at carefully. In case of the Norton's theorem, many times there will be the issue because we are doing the short circuit. And whenever we are doing the short circuit, sometimes calculation may be the clumsy. Is it right? I will come back to you, all of you. I will discuss which method will be suitable for this particular calculation. Which method will be suitable for this calculation because we are interested in the calculation of current in this short circuit, which is the Norton's current. I will come back to you. Yes. Anyone has a clue about these answers? How to calculate or procedure to be exact? I will start with Saurabh.
Yes sir, mesh analysis.
Mesh analysis. कितने meshes है यहाँ पे?
2 mesh.
कौन से 2 mesh है?
एक सुपर है और एक सिंगल.
Look at here. This is one loop, second loop, and this will be the loop again. Is it right?
Okay.
Yeah. It is not the 2 loop. We have the 3 loops. Otherwise, we have to modify this figure. Ruchira. Which method will be the suitable? Yes. Okay, fine. I will come back to you. Rohan. How to calculate this IN? How to calculate this IN? How to calculate this IN?
I don't know, sir. I am solving.
Sorry?
Sir, I don't know.
You don't. Why you don't know? You're not attending the lectures. You're not focusing on the lectures. You have to be serious and sincere. Because without effort, no one is going to pass you. Yeah. Rishikesh.
Sir.
How to calculate the IN?
Sir, लूप 1 लूप 2 को सुपर मेश और लूप 3 को सिंगल मेश मेश एनालिसिस
कर सकते। ओके फाइन। माधुरी,
mesh analysis.
mesh analysis कर सकते। Here I am asking to everyone. It means I am not expecting the in general or regular answers. I am expecting something new method. Is it right? कुछ नया मेथड यहाँ पे यूज कर सकते हैं। Can you use the nodal analysis? Yes or no? I am expecting the answers from all of you. Can we use the nodal analysis for this particular figure? Yes or no?
Yes, sir.
We can use. No. Let me explain. ये थोड़ा सा typical problem है. Means whenever we have the short circuit path is a parallel to any branch. इसके सॉल्व करने के बहुत सारे तरीके हैं. I will discuss one by one. In this case, first method तो ये है जैसे सौरभ ने स्टार्ट किया. This may be the loop 1, this may be the loop 2, this may be the loop 3. यहाँ पे केवल अप्लाई नहीं कर सकते, यहाँ पे केवल अप्लाई नहीं कर सकते, तो हमें केवल अप्लाई करना पड़ेगा इस सुपर मेश को. That is a mesh, super mesh. Then इस करंट ब्रांच से एक इक्वेशन मिलेगा, थर्ड इक्वेशन will get found. That is a little lengthy way. Other case, ये दोनों पैरेलल हैं. Whenever the short circuit is a parallel to any branch, the current will not flow through this path because everything will flow through the short circuit. Means I will draw first its equivalent figure. हर बार यही तरीका यूज करना जरूरी नहीं है. अपने जैसे डिस्कस किया कि 3 meshes भी assume कर सकते हैं and we can do that calculation. और ये दोनों parallel है. How is the parallel combination? 0. This next figure will be something like this. This next figure will be something like this. It is something like this. Is it right? कुछ इस तरह से होगा. This current is 3 amperes. This is 4 ohm and this is 24 ohm. Now we'll come back to you, Saurabh. ध्यान से सुनना. This branch has a 0 resistance, and whenever any branch has a 0 resistance, we cannot use which method? Nodal analysis. Otherwise, we have to use the super node. यहाँ पे super node भी use नहीं कर सकते. Is it right? When we will use the super node, if this branch has a voltage and 0 resistance, then we can use the super node. But when any branch has a 0 resistance, we cannot use the super node because in this case, if we are trying to find out its current, potential difference divided by its resistance will be 0. इसलिए जब भी नोडल एनालिसिस यूज करते हो आप किसी भी कैलकुलेशन में, मे बी द नॉर्टन थ्योरम, मे बी द थेवेनिन थ्योरम, मे बी द सुपर मेश सुपर नोड एनालिसिस और मे बी द सुपरपोजिशन थ्योरम, व्हाटएवर, whenever there is one path which has 0 resistance, think twice while applying the nodal analysis method. Is it right? Now, in this case, I will use the mesh analysis. This is the mesh 1 having its current I1. This is the mesh 2 having its current as the IN, because current in the short circuit is the IN, which is the Norton's current. यहाँ पे भी हो सकता था कैलकुलेशन, लेकिन यहाँ पे 3 लूप्स होते. इसको मैंने what I have done? I have done this parallel combination which is 0, and I have taken this figure which is simple. This is plus minus, and there is no need to apply because this circuit is so simple that it will increase the complications. इतना simple है कि उसकी वजह से यहाँ पे complications create हो रहा है. That I am trying to discuss here. Now, how is the KVL? We cannot apply the KVL to this. I will use the KVL to the super mesh. I will start from this point. How is the case? We are traveling clockwise. Negative to positive plus. Its voltage is 24. Then positive to negative is minus 4 into its current, which is I1. Then there is no element which is equal to 0. How much is I1? This I1 is equal to, how much is I1? This I1 is equal to, I will shift this value to the next side. It is 24 divided by 4. I guess it is 6 amperes is the I1. If we know the I1, already this value is known, which is 3 amperes. Is it right? Now, how much is the current in this branch? In this branch, current is the IN. And how to find out that value? We will find out the relation from this current source branch. I will use applying KVL. Applying KVL. Super mesh. This is right. And here, from current source branch, what we will get from the current source branch? This is upward. 3 amperes is equal to, which is the upward current? This IN is upward. That's why IN minus this is downward. This is upward, this is downward. I1. Therefore, this IN is equal to 3 plus I1, which is equal to 3 is the constant. I1 we have already calculated, which is 6. That is equal to 9 amperes is the IN. 9 amperes is equal to IN. Is it right? This is IN. If we know the IN, then we will find out the RN. And here, for the calculation of RN, also load resistance is removed first. Load resistance is removed, and all sources are replaced by respective internal resistances. How is the figure for this calculation? This is current source replaced by open circuit. This is voltage source replaced by the short circuit. Already load resistance is removed. Here is one branch, and this will be the another branch. This is A point, this is B point. This value is 12 ohm, and this value is 4 ohm. Now, this Rn is equal to 12 into 4 divided by this 12 plus 4. How much is the value? How much is the value? 48 divided by 16, I guess. This 48 divided by 16. It is 3 ohm. Yes, 3 ohm. And when we know these values, I will write here. When we know IN and RN, complicated network is replaced by Norton's equivalent network. Norton's equivalent network. This is right. How is the Norton's equivalent network? I will draw. This is the Norton's equivalent. And we are interested in this calculation of the Norton's equivalent network itself for this figure, because the question is find the Norton's equivalent network, and its IN is 9 amperes. This IN is the 9 amperes. And how much is the RN? RN is 3 ohm. This is 3 ohm. This is A point and this is B point. This is the answer. Because in this case, we are interested in the calculation of the Norton's equivalent network for this particular field. That's it about this particular problem.